Ever watched Star Wars and found yourself wondering, could lightsabers actually exist in our world? The allure of these radiant blades is undeniable. Imagine wielding a sword of pure, controlled energy, capable of slicing through the hardest materials as if they were warm butter. The lightsaber, an iconic symbol of the Star Wars franchise, is more than just a weapon. It's a marvel of technology, a beacon of hope, and a symbol of power. In the Star Wars universe, these gleaming blades can cut, melt, and burn through most substances with ease. They hum with the promise of raw power, sizzle with the thrill of the fight, and glow with the steady assurance of defense. But could such a weapon exist outside the realm of science fiction? Could our understanding of physics ever allow for the creation of a real functioning lightsaber? Now, let's delve into the physics behind these iconic weapons to understand if they could ever become a reality. To understand the feasibility of a real-world lightsaber, we first need to comprehend the physics involved. Let's start with the central concept of a lightsaber. The glowing blade is often imagined as plasma contained within a magnetic field. Now, plasma isn't as alien as it may sound. It's simply the fourth state of matter, joining the ranks of solids, liquids, and gases. When enough energy is applied to a gas, it ionizes into a state of free-flowing ions and electrons, creating this glowing plasma. This could theoretically be the source of a lightsaber's glow. But how do we keep this plasma in a blade shape? Enter magnetic fields. Magnetic fields, like the ones surrounding our Earth, have the capability to control charged particles. In theory, a sufficiently strong and well-designed magnetic field could contain the plasma within the blade-like form of a lightsaber. This would make the blade both visible and tangible. However, this is where we hit a snag. The energy required to create and maintain such a system would be immense. We are talking about enough energy to ionize gas into plasma and then contain it within a magnetic field. To put it in perspective, it's like trying to power a small city with a device no bigger than a flashlight, and that's not the only issue. The heat generated by such a device would be enormous. For a lightsaber to work as depicted in Star Wars, it would need to contain its heat within the blade without radiating it. Otherwise, the wielder and anything in close proximity would be subjected to severe thermal radiation, basically a heat wave intense enough to cause serious harm. So while the concept of a lightsaber is fascinating, it's not without its complications. The energy requirements and heat management alone present significant hurdles. Given these complexities, the creation of a real-world lightsaber faces significant challenges. So given our current understanding of physics, could we create a lightsaber? Well, there are a few obstacles we'd need to overcome first. First off, we'd have to figure out how to generate and contain plasma in a portable device. That's no small feat, considering plasma is superheated gas with enough energy to burn through just about anything. Then, we'd have to manage the enormous energy requirements and heat generation. Imagine carrying around a device that's hotter than the surface of the sun. It's not exactly practical. On top of all that, we'd need to create a blade that stops at a fixed length. Current technology doesn't allow us to do that without some sort of physical barrier. While the idea of wielding a lightsaber is undoubtedly fascinating, our current understanding of physics suggests that it remains firmly in the realm of science fiction. But who knows what the future holds? After all, science is always full of surprises.